Welcome to the Network Engineering Video Blog. I'm your host, Michael Crane. Well, this is going to be a follow-up video to a previous video we had on static routing, and I'm just going to call it part 2. So, in the previous video, we worked on routing between our Cisco router and our Juniper router. Now these routers are going to be, this is going to be in Dallas, this is going to be in New York. This right here is the trunk in between them that will run over our service provider, right? But in our test setup, it's just a wire, okay? But it should behave the same, or it will behave the same, okay? And that's what we did. So we were able to set up a static route in the Cisco and in the Juniper, so devices hanging off this network down here could come and ping devices hanging off this network, and vice versa. All right. One thing we didn't do though, as that video was already getting pretty long, is we didn't do the management side of it. Today, we're going to look at the management side, and what we're going to do basically is we want to be able to, from our management network, basically is we want to be able to ping devices or get to devices that are in both networks. So we want to be able to get to these networks, or at least the devices hanging off these networks. So that's what we're going to do today, and that's going to require some more static routing, which we'll look at here in a second. So anyway, that's pretty much the summary of it. So let's get started. Here's the test bed drawing that we did in the previous video, and I made a couple changes. I put part 2 on here and .175 because my laptop has changed IP addresses due to DHCP. And the goal is we want to be able to, from the laptop right here, we want to be able to ping devices hanging off these networks right here, okay? So we need to be able to ping, like that. And then come through here, because you have to remember, this is in New York and this is in Dallas, right? So having it go through one and back all the way across the other would be silly. So okay, so how are we going to do that? Well, what I did is I pulled up our trusty Xena piece of test equipment right here and set up a couple ports on the on both the Dallas and New York network. And let me see here. Yeah, so if you look right here, so here's the, so it's on port 1 of the Xena Compact, and it's using 172, 116, 192, 168, 11.16. And on the Dallas side, it's on port 0, and it's going to be 172, 192, 168, 10.16. Okay? Okay, and I apologize if I'm going pretty fast showing you all this. I want to make this video somewhat short. The goal is from the PC to be able to ping each one of these Xena Compact ports. Okay? And so what we're going to do is this is my laptop down here. This is the New York router, which is the Juniper. This is the Dallas router, which is the Cisco router, or the Dallas Gateway, which is the Cisco router. And just to show you that I can ping 192.168.11.16. Okay, that's pinging the Xena on the New York side. I can also ping it on the Dallas side. Okay, and that's going this direction. So the Juniper, I was able to ping the Xena down here, right? And I was also able to come across the trunk we provisioned in the last video, and then come down here and ping the other port right there. And we'll do the same for the Dallas gateway. We'll just do a ping 192.168.10.16. Okay. And we'll do 11.16. Okay. So that works, right? So, and basically what I did, I just went the opposite direction. I pinged this guy and down this way, right? So let's try it from the PC, okay? So I'm going to do a ping 192.168.11.16, and it fails, right? And we'll try 10. Okay, and we kind of expected that, right? Okay, so, and the reason it's failing, as you probably have guessed, is the laptop has no idea where the .10 network and the .11 network are, right? So, because we've got the .1 network in between, and it's kind of like what we were talking about on that last video, where the Juniper and the Cisco couldn't find either of the networks because this 172.16.0 network was in the way, or was in the middle, right? So he doesn't really know. And so we need to tell the laptop, okay, well, the .10 network lives that way and the .11 network lives that way. And we do that with a route command. Well, there's a couple ways to do it, but we're going to start with a route command in the PC. All right. Okay, and so that command is oh, and to look at the routing table inside a PC, you just do a route print, right? And here's the IPv4 routing table right here. And as you can see, its default gateway is 1.1. So 0.0.0.0, 0.0.0.0. Does that look familiar? And then it shows the next hop, which they call it the gateway, right? And it's coming from interface .175, which is on the laptop here. So, and this router right here doesn't know how to get to these two networks either, and that's actually the second fix, but let's talk about the first fix first. So we just want to tell the PC where it lives. And to do that, it's we're going to add a static route to the PC, and it's route add 192.168.10.0 mask 255.255.255.0, and its next hop is going to be 192.168.1, right? Because this is going to be our next hop right here. So it's going to be 1.75. All right. And then the second one is going to be route add 192.168.11.0, same mask. And it's going to be .77. Right? Right there. So basically we're telling them that you need to come down here to get to the .10 and come down here to get to the .11. Does that make sense? Okay, so we'll enter that. Now let's try them. So now we'll try to ping 192.168.10.16. Excellent. So now it knows how to get back, right? Or it knows how to route. It knows where to send the packets, and the Cisco, of course, knows how to route them back to the .1 network. So that's good. Now we'll try the .11 network. So it's ping 92.168.11.16. Uh-oh. It's failing. Why is it so? So Juniper considers any network that's connected to a network interface card inside the Juniper, in other words, this network right here, is considered in-band. So to be able to communicate with this network, we're basically coming through the management port and then going in-band to get to the devices in here. And if you look at this article right here, can the FXP0 interface be used for in-band traffic routing? And we could read the whole thing. I'm not going to read you the whole thing, but it says basically the FXP0 interface on the Juniper routers is expressly designed to be an out-of-band management port for your router. It is not designed to support or be configured with advanced features that many other Juniper PICs are designed for. Well, I didn't know routing was an advanced feature, but I guess so. And you can go on and read the rest of this stuff. But it says right here, Juniper recommends when using any gateway protocol configuration that uses interfaces all, that you should disable FXP0 so it will not be used for routing lookups. And that's kind of a long way to saying that it's talking about routing protocols, but even static routing will not work. And our default gateway is a static route, right? So the fix for this is we're going to have to move our management interface from FXP0 right here to a network card that will support static routing. Okay, so we're going to have to provision another port. And I only have one available left, and that is Fast Ethernet 033. So we're going to do and we can look at the config, but trust me, I only have one left. So, okay, so it's going to be edit. And let's see here. It's going to be set interfaces Fast Ethernet 3. Okay, it's going to be unit 0 and family inet address. And we can't use the same address because it'll complain severely about that. So we're going to give it another one. It's 192.168.1.78 /24. And so we're going from 77 to 78. All right. And just see. I think that's it. Hit enter. Let's go ahead and commit this. And see, it's complaining because FXP, now it's got two ports, FXP0 and FE033 are both on the same network. And this is why that knowledge base article was saying talking about disabling FXP0, because you don't want it to try to route stuff out of FXP0 since it can't route, right? And you don't want it in the routing lookup tables. Okay. So anyway, let's test that. Let's see if this works. So let's try pinging 11.16 now. Oh, and it doesn't work. And I know why it doesn't work, because we haven't added our route. So we've got route add 192.168.11.0 mass 255, 255.255.0, but it's going still to .77. We want them to go to .78. Oh, and another thing I haven't done either is I haven't moved the cable, have I? Okay, so let me go move the cable. Okay, so the cable's been moved. We've probably lost our network access. Yep. So I'm going to have to fire up another session. There we go. It's .7. So now we're going through .78. See, the old one was .77 up here, and it's going to X him out. We don't need him anymore. And Juniper 1, CLI. Okay, so I've moved the cable. We've changed our route in our PC. Now let's try pinging them. And there it is. We've fixed our little routing problem, but there's a couple things we need to do. First, we need to clean up FXP0, because if we do a show chassis alarms, you can see that FXP0 is down, and that's not good. So and it's also still provisioned. If we do a show config, you can see it's still in there. So the first thing we're going to do is we're going to disable FXP0. So we're going to just do edit, and then we're going to do a set interfaces FXP0 disable. Okay. And another thing I'm going to do is I want to get rid of the address in here, because even with it disabled, if I try to do a commit, it's going to constantly complain about that duplicate address, and I don't want to live with that. So we're going to do a set interfaces FXP0. We're going to do a delete interfaces FXP0 unit 0. Okay, now we're going to commit that. Okay, and you can see it doesn't complain anymore, and we'll look at our config real quick. And you can see as FXP0 has been disabled and it has no IP address. Alright, let's make sure our ping still works here. Yep, that still works. And if you want to clean up your PC, you can just do a route. What is it? Delete, I think. Delete. Don't make sure you don't delete your good one. We want to delete the .77 one, so you just hit enter. Okay, and we can look at our routing table if you want. Route print. Go to IPv4 routes, and they are right here. There's the 10 and 11. All right. Excellent. Okay, so you might think that's a pretty good fix, and it is for a quick and dirty. It's not permanent. I mean, you can add persistent routes in your PC. So if you do a route add and put a hyphen P in front of it, the hyphen P stands for persistent, which means it will live after a reboot. Okay. But the only reason why this fix works right here is because the Juniper and the Cisco both know how to route to the 192.168.1 network. If this laptop right here was on another network, in other words, like the 192.168.2 network, and the Cisco's only knew about the .1, it would not know how to get there, and so it would try to send it to the default gateway. And the default gateway off the management network is 1.1. It's not on this drawing, but I'll try to draw it in here a little bit. This is .1. Okay, I'm sorry that looks so bad, but and this router right here does not know how to get to the 192.168.10 network, and I can show you that. So if I can find the window, here we go. So here's the .1 router, and if I try to do a ping 192.168.11.16, right, it can't find it, right? And we'll try the .10, but I can tell you it can't find it, right? And the abort for ping on Cisco is Control-Alt-6. Hit it many times. Sometimes it works, sometimes it doesn't. I don't know why Control-C doesn't work. That is such a Cisco POS. It's beyond belief. But anyway, I digress. So this router right here does not know how to route back. And so, you know, if this laptop is not anywhere on the .1 network on any network that the Cisco or Juniper know about, then it's still going to fail. So our persistent routes in this wouldn't work in another network if there was a network in between, that is. So we can add. So the fix is, of course, to add some static routes inside our .1. Router right here, okay, and that will fix everybody right here. And another thing too, if you just put those static routes in your laptop, then any of your coworkers that want to try to access this will have to add the same static route, which is a pain. So the real solution is putting the static routes inside this third router. And as you can tell, so right now we're just trying to route one laptop to these two networks, and we've had to add static routes in now 3 routers. And this is where routing protocols shine, because they automatically update their routing tables. So when you add a new network on one of the Junipers, or the Juniper or the Cisco, it automatically updates all the other routers around it, and you don't have to add all these static routes. Okay, so I'm going to go ahead and add those static routes in this router just for this video right here, so we can verify it works. So it's config T IP route 192.168.10.0 255.255.255.0. Next hop is 192.168.10.75, right? And we'll go ahead and add the Juniper. See, it's .78, and that will be our 11 network. Okay, Control C and write that. Okay, so now let's try pinging these guys. So ping 16 first. And that failed. Why is it? Well, it's because my head's not screwed on straight. So let's try that again. Config T. And I'm sure you saw it when I was doing it. So it's IP route 192.168.10.0 255.255.255.0 to 192.168.1.75. Not .10. Still doesn't know how to route to .10 yet. And yeah, that was just a brain fart. Okay, and I even made another mistake with this guy. Looks like right here. I was messing everything up. So okay, let's try that again. So we want to route the 11 network, and it's 1.78. Okay, Control C and write that. And let's give this thing a try again. So ping 192.168.11.16. Ah, perfect. It always helps to get the numbers right. We'll try the .10 network. Perfect. Okay, so now we got those two routes plugged in our third router. Go ahead and move him off the screen there, and let's go ahead and delete these routes. So we're going to do a route delete. Okay, so that was 11. Let's do the 10. So it's route delete 92.168.10.0 mask 255.255.255.0 192.168.1.75. All right, let's do a route print just to make sure they're gone. And there's a default gateway. Yeah, so they're all gone. So what's going to happen now is when I ping from the router, he doesn't have that route in his routing table, right? So he's going to use the only route that he knows of, and that's going to be the default gateway. And on the Juniper and Cisco, here's a Juniper up here. His default gateway is also the 1.1, and it's the same in the Cisco. If we do a show config, and there it is right here. So they both have it. So everybody should default gateway is set there. We'll check it on the PC here real quick. Ping 92.168.11.16. Yep, that's working. Try the 10. And that's working too. Excellent. So now, everybody that's on the .1 network, or the .10 network, or their .11 network, will all be able to communicate with each other, which is the way we want it. So you can see why, right now with just 3 routers, how much work it is to add static routes, and why routing protocols are used so much. But don't discount static routing, because even routing protocols use static routing, and we'll get to that when we start doing protocols like OSPF, BGP, all that other fun stuff. So you always need to know how to manually route something, because if you can't manually route it, a protocol is not going to be able to route it either. So you can always test doing that, and using those extended ping commands are very helpful, that we talked about in the previous video for debugging this. On that note, I think that's about it. So if you like this video, give it a big thumbs up. If you have any questions or comments, leave them in the comments under the video. I'll try to answer them the best I can, and I'll see you next time.